if you're not already familiar with the Transit Gateway, we'll just talk about that real quick here. Transit gateways, you can think of them as very simple but super powerful cloud routers. You can attach them to your VPCs and to your interconnect infrastructure. You can even attach SD-WAN devices to them or anything that can tunnel GRE, and then use that to control all of your routing and forwarding in your virtual environment. It's awesome. But the main problem with them is that they're kind of a black box. You configure subnet or VPC level route tables to forward traffic into the transit gateway. But then what happens is that when that traffic is shunted over to the router, you lose visibility. And transit gateways support both static and dynamic routes. So if you're having connectivity issues, you sort of need to know where a packet was forwarded at any given point in time. So you need to know how that traffic's flowing. And maybe you need to answer this question because you're working with a company, working with a team that's making a change to their network. Maybe you're working a ticket that's trying to figure out why a container in a subnet's not able to communicate with another subnet. In AWS, the process to find this traffic flow looks like this. It's almost funny. So you log into the console, you go to the EC2 UI, you find the VPC ID that's associated with a particular instance. Then you change to the VPC UI. You find the route table UI. You find the transit gateway associated with the VPC ID. Then you change to the transit gateway UI and you find the transit gateway associated with the VPC. And then you change to the transit gateway attachment UI and find the attachment ID associated with that VPC. Then you change to the transit gateway route table UI and you find the route table associated with the attachment ID. Hopefully you have not forgotten to copy as you're going along because you're doing a lot in copy and paste. I assume that if folks are paying attention right now, they're nodding their heads because this is what life is like when you're doing this stuff in AWS. So it can get a little ugly, and then it can get really, really ugly if you're starting to chain along one transit gateway to another, which we'll see here in a minute. So how does this look better when we do things, getting ahead of myself, when we do things in Kentik? Let's take a look. It's pretty easy. So remember our use case here is that we want to show traffic through a transit gateway and be able to trace the path that it's going to take. I'll do a little bit of orientation of the product as we go along. So I'm going to click into the Kentik Map. And then I'm going to drill into the Amazon map here. All right. So what do we see? Bit of orientation. We've got the on-prem block. This is where if you've got the customer gateways or routers that terminate your VPN or your your direct connect devices registered in Kentik, they'll show up here. We don't have that in our demo environment today. But what we do have is a site-to-site VPN that's connecting us to our data center. And we've got a number of regions with VPCs in there. And we can see here that each region is represented by a gray box, and then each VPC inside that gray box is a purple card. Outside of these gray boxes, we've got lines showing traffic to and from these regions. And then over on the right, we've got our transit gateway architecture. So we can see here that in US East 1, we've got a transit gateway. It's peered up to a transit gateway in California, which is also peered up to a transit gateway in Singapore. And then we've got an orphaned transit gateway sitting over here in US East 2. Nothing's, it's not connected to anything. And we can see here that the transit gateway is actually connecting out to these different VPNs, which then brings us back to our on-prem network. Okay, so we can click on any of these VPC cards to drill in and get a sense of the VPC architecture. So in this case, we've got prod app here. There's a VPC ID and the CIDR block associated with it. And we've got the different availability zones that prod app is deployed into and the subnets in each zone. And so down here, we can see the other VPCs in an expanded form. We can also see that this traffic from US East 1 to US West 1 is going over an internet gateway. Not great. And we can see the gateways below it. And we can also see how transit gateway attachments are routed back up to the transit gateway themselves. So below that, we've got these different VPC cards, and we can see that based on the numbers in each card, how much traffic is going to and from the selected VPC. So I'm going to choose this VPC here. And let's say we're interested in this subnet here, stage AZB. And we want to be able to understand where traffic is flowing out of this thing through the transit gateway and so on and so forth. So first thing I can do is I can say, show my connections. And right there, we can see this is a very busy UI. I'm sorry, very busy subnet. Over here, we've got mesh, so you can see that by design, this thing's talking to every single thing. And we can hover over any of these lines to get an at-a-glance viewing of how much traffic is being sent from subnet to subnet or down to the different gateways. All right, so let's also show you what we can do when I click on hide connections, and then, actually I'll keep that up, and then we'll do show details. So now on the sidebar, we have the traffic that's originating in this subnet. And then below that, critically, we've got the route table that's associated with this subnet. And we're showing that we've got a black hole route set up in this subnet. Don't know why that is yet. Maybe we'll find out later. And then we can also take a look and say, okay, this traffic is coming out of this subnet. What are the IPs that are communicating here? So I can just do an IP query, for example. All right, now we can see the IP pairs, and because we keep context in there, what if we wanted to do instances? All right, so now we know the instances that are associated. So if those IPs are ephemeral, we'll keep track using the instance metadata instead of the IP. All right, but we're interested in traffic out. So we know that the on-prem network is 192.168.0.0. So let's come down here to the route table and just see what it says. So we see that 192.168.0.0.16 is going to the transit gateway. That's good. So I'm going to go ahead and copy the transit, or the route table. Or I'm sorry, the route that we're interested in, and let's just take a look at, follow the line from the transit gateway up to, from the attachments to the gateway, and then we're going to do the show details. And now we're going to pull the transit gateway route table. And if you're not familiar, transit gateway route tables are kind of like VRF route tables, where you can have a different route table for each attachment. So let's see which VRF has that. And so we see here that we've got this attachment, and we're going to forward all traffic destined for 192.168.0.0 to this VA to CA peering attachment. So that tells us, not surprisingly, that this is going to follow this peering attachment down to this other transit gateway. This is where it would be an incredible nightmare to do this in AWS. So now we can do the same thing down here. Let's say show details, open the route table for this aggregator. And we can see now that we've actually got two different VRFs with this route in it. And both of them, luckily for us, are going to send that traffic straight up to the VPN hub. So we follow those lines, and we're over here in the VPN. So just to recap what we've seen here, we've followed traffic from a subnet down through a gateway attachment up to the transit gateway, down to another transit gateway that's aggregating a number of transit gateways, and out to the site-to-site VPN. So we now know the full path, and we now know how to begin digging in a little bit further.